Starship Flight 13 is fully stacked right now on the pad in Texas. 120 meters of rocket, targeting liftoff within hours. 20 real Starlink satellites are loaded inside, waiting. SpaceX appears set to skip a critical pre-launch safety test just to hit this window. That's a bet most rocket programs never make. So what happens in these final hours before liftoff? Stay with me. Let's rewind 3 days. July 12th, Booster 20 rolls back into the production site after weeks of testing. At that point, nobody outside SpaceX knew how fast things were about to move. Most people expected a slow, methodical process. Final checks, paperwork, maybe a week of prep before rollout. That's not what happened. By July 14th in the afternoon, the booster transport stand is already outside Mega Bay 1. Road closures get announced. B-20 starts moving toward the launch site. Chopstick arms lifted onto the orbital mount. Engineers test the grid fins. Think of those as the rocket's air brakes, the fins that steer it back down through the atmosphere during landing. Everything checks out. 2 days. That's the entire turnaround time from back in the factory to sitting on the launch pad, ready for flight. For a vehicle over 70 meters tall, weighing hundreds of tons, that speed is almost unheard of. So here's the first question worth sitting with. Why the rush? While B-20 was racing to the pad, Ship 40 was going through something far more delicate. On July 7th, a payload loader showed up at the production site, but it didn't go inside Mega Bay 2. Not yet. That's strange. Why bring the equipment and then just wait? The answer took a full week to arrive. On July 14th, S-40 was pulled outside Mega Bay 2 on a transport stand, not to head to the pad, but to make room. Room for the payload loader to finally roll in. Once the building was clear, S-40 went back inside to receive its cargo. And here's where the story gets bigger than just another test flight. Flight 13 is carrying 20 real version 3 Starlink satellites, not mass simulators, not dummy weights bolted in for balance. Real, functional satellites, with solar arrays, cameras, and antennas built to talk directly to the existing constellation already orbiting Earth. Think about what that means. Every previous Starship flight has been about proving the rocket works. This flight is about proving the rocket works and does its job. It's the difference between a car passing a test drive and a car actually delivering packages on schedule. That shift, from testing hardware to running a mission, is the real headline buried inside Flight 13. The test SpaceX appears ready to skip. Normally, before a Starship launch, SpaceX runs a full wet dress rehearsal, the last safety net before committing to flight. Because rollout happens so close to the launch window, all signs point to SpaceX skipping it this time. A rocket over 120 meters tall carrying real satellites may fly without that final check. If you want the full breakdown of what that test actually involves and why skipping it isn't as risky as it sounds, I covered that in detail in a separate video. Links on screen now. What matters here is the bigger pattern. Because this isn't just about one test being skipped. It's about a company that's clearly optimizing for speed on purpose. And that raises a much bigger question. Bigger picture hiding behind one launch. Last month, SpaceX President Gwynne Shotwell said something that didn't get nearly enough attention at the time. She predicted Flight 13 would launch in July. That prediction is holding up. And she said something bigger was coming after it. Monthly Starship launches, starting with Flight 14. That's not a small claim. Building and launching a rocket this large, this complex once a month, is a pace no company has ever sustained with a vehicle of this size. So what's the evidence that it's actually possible and not just a goal on a whiteboard? Look at what's already lined up behind Flight 13. Ship 41 started construction in mid-April and was finished by the end of June. It's already been to the test site twice for cryogenic testing, essentially filling the tanks with super cold propellant substitutes to check for leaks and structural weak points under extreme temperature. Its most recent trip was in early July. Raptor engine installation is likely happening right now, this week. Booster 21 is moving just as fast. Construction began in early May. By the end of June, its forward section, including the hot staging ring, the part that lets the booster and ship separate cleanly mid-flight, had already arrived at Mega Bay 1. If Booster 21 finishes cryogenic testing this month, a static fire test, engines igniting while the vehicle stays clamped to the ground, could happen in the first half of August. Based on how fast B-20 moved from testing to flight ready, Flight 14 looks genuinely on track for the second half of August. That's 1 month after Flight 13, exactly what Shotwell predicted. Here's the part that should really change how you see this moment. SpaceX isn't just building one rocket at a time anymore. They're building 3 generations simultaneously. While Flight 13 sits on the pad and Flight 14's hardware gets its engines installed, Flight 15 is already under construction. The first sections of Ship 42 arrived at Mega Bay 2 earlier this month. Booster 22 started stacking in late June, and there's a detail here worth pausing on. Flight 15 might not launch from Texas at all. Based on earlier comments from Shotwell, there's a real possibility it launches from Florida. If that happens, it's not just a change of scenery. It's SpaceX proving the entire Starship operation can be replicated somewhere else, which is exactly what you'd need if the end goal is dozens of launches a year instead of a handful. So ask yourself, what does it mean when a company is simultaneously flying one rocket, finishing another, and pouring the foundation for a third? That's not a test program anymore. That's a production line. Why this race actually matters. Now here's the part that turns this from cool rocket news into something with real stakes attached. In the first half of 2026, SpaceX didn't fly Starship at all. More than 7 months passed between Flight 11 and Flight 12. 7 months of silence, while engineers reworked major parts of the system. That gap wasn't wasted. It led to real upgrades. But it also cost something you can't get back, time, and NASA is watching the clock too. Artemis 3, the mission meant to put astronauts back on the moon, is targeted for around the middle of 2027. Before Starship can serve as the actual landing vehicle for those astronauts, it has to prove, over and over, launch after launch, that it's reliable, not once, repeatedly. That's the real reason the monthly cadence matters so much. It's not about bragging rights or setting records. Every flight is a data point. Every successful mission shortens the distance between experimental rocket and vehicle NASA trusts with human lives. A 7-month gap between flights doesn't just slow down SpaceX's ambitions. It puts pressure directly on a timeline NASA has already committed to publicly. So when Flight 13 lifts off, it's not an isolated event. It's the first heartbeat in a rhythm SpaceX is trying to prove it can sustain, with a lunar mission and real astronauts sitting at the end of that timeline. Here's where this story takes a turn worth sitting with. Everyone's focused on the rocket, the stacking, the countdown, the satellites. But look again at what's actually driving this pace. It's not the launch itself, it's the factory behind it. 3 ships and 3 boosters, at 3 different stages of construction, moving through the same limited set of buildings, Mega Bay 1, Mega Bay 2, the test site, without stepping on each other's schedule. That's not luck. That's a manufacturing system being tuned in real time, the same way a factory line gets faster the more times you run it. And that's the real twist buried inside this story. Flight 13 looks like it's about a rocket launching, but what SpaceX is actually testing quietly in the background is whether Starbase itself can function like a factory instead of a workshop. Whether Mega Bay operations, cryogenic testing, and static fires can all run on overlapping schedules without one delay collapsing the entire pipeline. If that system holds, if Flight 14 really does launch in August, like the hardware is suggesting, then the story isn't SpaceX launched a rocket. The story is SpaceX built a rocket factory that works. And that changes everything downstream. Costs drop, turnaround shrinks, and the leap from monthly launches to weekly ones stops being a fantasy and starts being a math problem. So as Flight 13 sits on the pad, fully stacked, hours from liftoff, the real question isn't just will it fly, it's whether what happens next, Flight 14, Flight 15, and beyond, proves that SpaceX just quietly solved the hardest part of building a Moon and Mars program, not the rocket science, but the assembly line underneath it. If this helped, hit like, comment your take, and subscribe to the Space Brief. I'm Adrian. Thank you for watching. One more video is waiting on your screen right now. Keep